Hello everyone, and welcome to this Green Building Pro online event series broadcast, Merging HVAC and Lighting Controls for More Cost-Effective Green Buildings. This webcast is brought to you by Green Building Pro and is sponsored by SourceCore Professional Services. I'm Mitchell Funk, editor of Green Building Pro, and I'll be your moderator today for this webcast. In a few moments, Louis Hamer will join us to discuss how to combine HVAC and lighting controls using technology to enhance the efficiency and cost-effectiveness of green buildings. First, I want to go over a few housekeeping details. Our livecast environment, is intended to be completely interactive, so everyone will have the ability to post your questions at any time during the broadcast or chat with other attendees about the session you're currently watching. You can use the live chat box directly below the webcast window. In addition to that, you can also undock the chat box from the screen using the pop-out button at the bottom right corner of the chat box. That way, it won't get hidden behind any of the slides there. All of our presentations are expandable. If you ever need to get a closer look at any slide during the presentation, just hover your mouse over the video player and click the full button to expand to full screen. Today, we'd like you to share your attendance with everyone in the community. You'll see a rolling Twitter feed down at the bottom right corner of your screen where you can share your comments. If you are tweeting, we do ask that you use the #GBExpo hashtag when you tweet so that others know where you are and where to join in. If you'd like a copy of today's presentation materials, including the slides, you'll find a button to download a copy of them and other files under the Resources tab at the top right of the page. A recording of this entire live broadcast, including the Q&A, will also be available within 24 hours, so you can come back again or recommend it to a friend. And with that, I'm going to introduce our speaker joining us today. Louis Hamer is the Vice President of Product Strategy at SCL Elements Inc. Louis Hamer is a registered professional engineer and an accredited lead professional. He graduated in electrical engineering from the University of Sherbrooke's co-op program and has also completed technology product management and entrepreneurship training by MIT. He is a frequent contributor to various local and international conferences and publications on the subjects of energy efficiency, greenhouse gas reduction, wireless technologies, and network reliability and security. Before joining SCL Elements, he co-founded Eco2 Max, which is an engineering firm specializing in energy efficiency and building automation. And with that, I want to introduce you again, Louis. The floor is all yours.
Well, thank you, Mitchell. Hello, everyone, and thank you for joining us for this broadcast. So let me look right away into my presentation overview. So 4 things that I want to cover today. The first one is really look at controlling of HVAC and how that increases efficiency, and really looking at what is the percentage of energy consumption and what are the average savings. And then start looking at why is there an HVAC and lighting split? Why are both these control solutions have been split? And they're really it's based on historical and technological reasons, so I'll go over that as well. And thirdly, look at how new technology is basically bridging the gap and combining now HVAC and lighting. And then, what are the key advantages of combining HVAC and lighting controls? So what are the technical advantages, how it reduces complexity, and mostly how it offers, very strong economical advantages. And at the end of the day, how it, basically provides scalability and payback. So the chart that we have in front of us is the distribution of a typical U.S. office building, so typical distribution of energy. As you can see, HVAC is normally the main expense. You're looking at 25% of heating, 5% for your ventilation, and 23% of cooling. So just above 50% really affecting energy use for your HVAC systems. And then the rest is, everything from, water heating to office equipment to your lighting charges. Now, what's the efficiency of potential of building automation solutions? Well, there's 2 key reasons why people are installing building automation and controls. The first one and the primary one is to generate energy savings. and it's all about providing a return on investment on this system. People are ready to install building controls as long as it can provide a fast payback and by generating, energy savings and basically allowing, the building owner to recuperate his investment fairly quickly. The second reason is improved comfort. With the advent now of green buildings and LEED certified buildings, there is some strong data and lots of studies that prove that building where comfort for the end user and the occupants is improved will improve worker efficiency and basically generate even more savings. So what can it offer? Well, building automation solutions will basically offer automated, local, and remote control. So local basically allows the occupant greater control over comfort at the local level. And then remote control is basically from a centralized location being able to control your HVAC and lighting according to occupancy, schedules, and weather. And there's now a lot of emerging technologies that are basically allowing. Let me just the basic. There's many new things like CO2 sensors where they are being installed so that we can regulate the outside air intake. Traditional systems were providing a regular flow of outside air, without looking at if the building or that specific zone was actually occupied and fresh air was really needed. With CO2 sensors, you can, greatly reduce the amount of outside air to just what you need, and that really saves a lot in terms of energy savings. There's things like daylight harvesting, where systems are installed so you can actually dim artificial lighting based on the amount of natural light which is available. So there's great advantages. There are lots of new sensors that are available, and it makes for smarter and greener buildings. When you look at HVAC building controls, you're looking at generating in average, typically 5 to 30% of your overall energy consumption, whereas lighting building automation, typically will save between 4 to 10% of your overall energy consumption. So we can see, there's definitely a greater advantage of starting to automate your HVAC systems first, and then probably adding on lighting as well later on. When we look at building automation solutions and we look at market penetration rates, let's just look at the numbers first. When you see the small to medium buildings, so anything which is 100,000 square feet or less, we see that the penetration in those types of buildings is quite low for automation solutions. You look at 5% for HVAC and a very low 1% for lighting controls. And when you see that 98% of buildings in the U.S. are 100,000 square feet or less, we see that this is a fairly large market which is being totally underserviced right now. And if you look at the surface, these types of buildings actually represent 65% of floor surface available. When you look at larger buildings, over 100,000 square feet or less, the penetration rate is a lot greater. It's 43% for HVAC and 12% for lighting. But these buildings really represent only 2% of buildings and about 35% of floor space. So a couple conclusions from all this, first of all, it's quite clear that, there is a lot more penetration in terms of HVAC compared to lighting. We're looking at about 4 to 1. In favor of HVAC. So there's definitely some room to scale from HVAC to lighting and vice versa. And then we can also realize that the smaller buildings is really underserviced, and there's a lot of reasons for that. And it's primarily because of how traditional building automation solutions really didn't offer an ROI which made a lot of sense for those smaller buildings, and all had to do with fixed costs for those traditional solutions. And I'll cover some of those aspects today. So when we look at HVAC and lighting, there's really two sets of solutions, unfortunately. There's one solution for controlling your lighting, and then you need a separate, totally different and separate solution for your HVAC, which basically means at the end of the day, for each zone of your building, you need one controller or one box for your HVAC controls, and then you need a second box for your lighting. And then there are things like gateways, which are also basically duplicated. This, results in very high hardware costs. It results in installation overhead, maintenance costs, training costs. It's basically a very, very large burn from many different perspectives. Then, you need something to actually centrally manage all of this thing, and you need some software, which would be your building management system. And for many systems, you basically need two different sets of softwares running on two separate sets of PCs and dashboards to basically be able to monitor and manage all the, these two different lighting and HVAC solutions. So again, a lot of costs, a lot of training, a lot of overhead, a lot of installation nightmares. It just really makes things a lot more complex. There are a couple of systems that do integrate at the software level, and I'll talk a little bit about that in a couple minutes. From an energy cost point of view, well, we see a lot of or more HVAC controls than lighting, but very few buildings actually have both. Which is unfortunate, because you're out there, pulling wire, installing controllers. Why not be able to control both your lighting and HVAC and basically maximize your investment and maximize the energy savings? So at the end of the day, you're basically losing a lot of energy savings, and the scaling of all of these two separate systems is quite complex. So why is there a split between HVAC and lighting? Well, the key reasons, the first one is historical. Control solutions from an HVAC perspective and lighting perspective really, emerge at different times. A lot of times, these different systems were manufactured by totally different companies. You look at the lighting world, it's, you look at large companies like Leviton, Sylvania, great products, great control solutions, and they basically focus on, providing some lighting controls for their lighting products. And then on the other end, you have a bunch of these HVAC companies, the Johnson Controls, the Honeywells, and a bunch of other companies that have their HVAC equipment and came out with some equipment to basically control all of it. So you have, different companies, and then at the end of the day, you also these systems are being installed and sometimes maintained by totally different service providers. And then the other thing is, from a historical point of view as well, is when you look at protocols. From a lighting perspective, you have protocols like DALI, which are fairly used for lighting. But from an HVAC perspective, the protocols that have been used are things like BACnet and LAN. So again, some technology reasons, but as well historical reasons where different protocols were invented at different times. And then the technical reasons, well, there's always, the logistics of wiring. There's always the limit of I/Os, so inputs and outputs that are available per controller. So you can imagine in a particular zone, if you have to control all of the lighting points and then all of your control points, your controller will max out on his I/O limit. So that might be some reasons to have two separate systems. But the key reason really is the concept of application-specific controllers and gateways. right from the start, because they were manufactured by different companies and because of limited hardware resources, from a RAM perspective, CPU perspective, really the hardware resources that were available in the controllers limited their functionality, and basically you were limited to doing very specific application control solutions. So you couldn't have a multi-use, fully programmable controller that can do different things at the same time because it just didn't have the horsepower to do it. These limitations were really the results of the R&D process, like I explained. They're limited to automation technologies, and they were really foregoing a lot of the IT and networking advancements that have been made in the last couple of years now. So how are we bridging the HVAC and lighting gap? Well, we're basically changing the whole R&D process and now looking at it from a transversal approach. So automation with IT and networking, what does that mean? Well, basically there have been a lot of advances, as you probably know, in embedded computing, with the advent now of smartphones and iPads and iPhones. The cost of RAM, the cost of CPU, the cost of all these different components, and just the being able to have a large volume and mass production of all of these different components now allows us to build controllers with a lot of horsepower and still be able to be very, very competitive in terms of pricing. And the advances in the networking, well, there's been, great advances in terms of networking technology in the last few years. Obviously, IP and Ethernet are now everywhere and prevalent, and unfortunately haven't really been used with traditional systems for controls. And then there are a lot of advantages and advances that have been made for wireless technologies. So you've got technologies like the N-Ocean protocol or Zigbee protocol that are now quite prevalent, that have been out in the market and proven in the field for many years now. In different spaces, they are now being used widely for building automation as well. Those types of networking technologies are really helping bridging the gap and basically providing standard-based and open protocols that people and different manufacturers can use so that all of the different components and the whole ecosystem can now start talking to each other. So when you look at the results, well, the wiring logistics, obviously you're still going to have to be wiring some end devices and some of your network controllers, but wireless communication for control is now something that is now quite prevalent and reduces a lot of the logistics, reduces the costs of pulling wire. Labor rates are rising. Labor for installing control solutions sometimes is a major factor in the end price. So if you can reduce all that with wireless technology, it certainly is a great advantage. The I/O limit per controller that I mentioned, well, this I/O limit can basically be totally erased now with virtual I/Os if you're using wireless sensors and actuators. So instead of needing a physical input or output on the controller, you can actually use a virtual wireless input or output. So you're really not limited to that number of physical connectors anymore. Then the notion of application-specific controllers. Well, there are now fully programmable controllers with enough horsepower to be able to do lighting and HVAC and do anything else for that matter, for everything from window blind control to any other control or any mechanized system that you would have in your building. People are now starting to mechanize windows, automate tinting of the windows. There's different new technologies now that are coming out, and all of this is possible because we've basically been able to embed into one single control solution all of these applications. And then the gateways, which were as well application specific. Well, what a lot of folks are doing now is they're basically saying, well, why do I need a separate gateway? Why can't I embed the gateway functionality directly in the controller? So you're basically removing yet another box, and I'll cover that in my next slide. So here are the three types of systems that are available. From the left-hand side, it's more of the traditional systems, and on the right-hand side, it's the more modern systems that are now available. So from on the left-hand side there, the parallel systems. Well, this is what I've been talking about today. You have a totally separate system for your HVAC and another one for your lighting. And you basically need end devices, controllers, gateways, and the software or interface. And you need this for both of your lighting and HVAC. Now, some manufacturers realized that this was a lot of overhead and that there really wasn't a need for two different software platforms. So they basically came out with, parallel control, but with the central interface. So that's the second image here right in the middle of this slide, where you see the end devices are separate, the controllers and gateways are separate, but the system gateways and the actual software interface for your building management system actually combines both HVAC and lighting. So that's, a first good step in the right direction, but with modern systems, now what we can do is basically combine the HVAC and lighting end devices, and then combine all that into one single controller and have this controller also act as a gateway so it can talk directly to your building management system. So as you can see, there are a lot less boxes, a lot less wires, and just a lot of less, complexity, maintenance issues, et cetera, et cetera. So this slide here sort of tries to illustrate all this. So on the left-hand side, you see the more traditional systems where you have, parallel control for your HVAC and lighting. So you see the lighting controller there, which is connected to a light sensor and your light switches and your lights and actual relays. This is actually, hooked up into a lighting gateway, which can then talk to your software building management system. And then, you have the HVAC controller, which is talking to the actuators and to the VAV boxes, the thermostats, and CO2 sensors, for example. And then there are other things like metering, occupancy sensors. What do we do with the occupancy sensor? In traditional systems, sometimes you may actually need two. One occupancy sensor hooked up to your lighting control and another one for your HVAC. So that's a lot of overhead. That's not always the case, but that is the case in some systems. Whereas on the right-hand side with the combined control, you see, there's one controller that's basically talking to all of the different peripherals from an HVAC and lighting perspective. It can talk to the meters, so you can have sub-metering as well in each different zone. And then, that occupancy sensor all of a sudden can now be shared between the HVAC and lighting. Why have two different occupancy sensors where you can have both? And in this slide, basically, all of very low manufacturers that are now deploying and manufacturing N-Ocean end devices. For example, I believe there's 160 that are manufacturing N-Ocean devices, which are all compatible. So it's based on an open protocol, and it basically allows end users, the flexibility of choosing the best of each manufacturer and really being able to combine all these different technologies into one system. So when we look at, the gains of combined control, there's obviously a couple. From a scalability point of view, the wireless IOs basically you can now add end devices without actually having to do some wiring labor, having to pull wire. So there's no downtime. I just stick the wireless sensor on the wall, and boom, you're up and running. It gets automatically configured into your system, and you can now start using that CO2 sensor, for example. Fully programmable, so there's one controller per zone, and because it's fully programmable, it can be used for both your HVAC and lighting or your window blinds, for example. And the embedded gateway, everything is sucked into the controller. From a payback perspective, and really that's the end game for most, and really what triggers the addition of building automation into a building. It's really, can we provide a good payback on this system? And if you can save on the labor with the less wirings, if you can save on the hardware, no more separate boxes for control of lighting and HVAC, no more gateways because they can all be handled at the controller level. And then you're saving a lot of money as well on your dedicated hardware, which needs to be running your software, which requires a costly license for your building management system. And so when you see that you can save on all that, and you can now combine the energy savings that your HVAC and lighting, so now instead of having 5 to 30% or 4 to 10, you're basically combining that. So typically now you can have up from 9 to 40% typical overall energy savings. So you can see that the payback period is basically being reduced by reducing the cost, but also by augmenting the energy savings that you're generating with the automation system. Then there's, well, how can you scale all this? And how can you scale it across a number of years? Well, this is interesting. If you look at, the merge wireless control for HVAC and lighting on the top there, a lot of folks will start with HVAC installations. They're limited in budget in year one, and they may say, you know what, I need to value engineer this building. I only have X amount of dollars in my budget, and I really want to maximize my building automation solution. So most folks will then decide to say, well, okay, I'll start by installing a automated central control system for HVAC, and I'll do that in year one. And then 3 years down the road, they've basically, generated some energy savings, and they now can start scaling the project and say, well, hey, why can't I add a motion detector? And then year 4, well, maybe I should start automating my lighting. Well, because the controller's already in place, and because you can add all of these end devices, which could be wireless, you can basically just add them on to a very low cost from a hardware perspective, but a very low cost as well from a labor perspective. And all of a sudden, you're basically adding on this thing, and you're generating even more savings, and it's actually been paid by the energy savings that you were generating from year 1, 2, and 3. And a couple of years down the road, year 6, you could say, well, you know what, I could add some CO2 sensors, I could add some daylight harvesting sensors to start dimming my lights automatically, depending on natural light available in the building. So you can see that, with a flexible system where you can add on things, it basically allows you to evolve your building and make it greener year after year, even if your budget initially was somewhat constrained. Whereas if you went the old way, on the bottom there, and you had a separate control for your HVAC and lighting, well, you can see that if you want to do that same thing, well, all of a sudden you need some I/O extenders to add on extra end devices like sensors and actuators. And then you need to add another box for your lighting controls and the gateways. And all of a sudden you're stuck with pulling a lot of wires. There's a lot of downtime associated with all this. And really a lot of the times the ROI just isn't there. So people are just not doing it, which is unfortunate. So the power of combining all this and the power of wireless systems is the shorter payback periods, which really allow a faster system upgrade for more energy efficiency. And the scaling from HVAC to lighting or lighting to HVAC really becomes a lot easier. So maybe a couple case studies to illustrate some of these concepts. A lot of times it's a lot easier to use some actual real-world deployments to sort of illustrate how powerful HVAC and lighting combined into one is going to be allowing a much greater penetration of building automation solutions, even in smaller buildings. So this first case study is an elementary school, about 8,000 square feet, 2 floors plus abatement. Central heating, before there was no local or remote control. There was absolutely no remote lighting control, and downtime and resource constraints were present. So downtime, this school is full. The school board was actually retrofitting all of their schools, so they couldn't do all the schools during the summer months. They had to do some of them during school hours, so downtime was a big problem, and resource constraints obviously as well. The school boards are not cash risk. So they had to come up with a solution where their return on investment was very interesting. And this is what they did. They basically had to deploy throughout the whole building only 9 controllers to handle both HVAC and lighting. The controllers were basically handling 60 HVAC end devices. So by end devices, we're talking about actuators and thermostats, and then 116 lighting end devices. So from a lighting end device point of view, you're looking at a lighting relay or a lighting switch. So as you can see, this was a fairly standard building automation solution. There's no CO2 sensors. There's no daylight harvesting. They really went for the standard approach, but the great thing is, as they generated more energy savings and as budget allows, maybe 2 or 3 years down the road, well, because scalability is possible, they can now start adding those CO2 sensors or daylight harvesting sensors as well. And you're now basically generating even more savings and allowing the school board to not only be a responsible corporate citizen, but also reduce their operating expenses dramatically. In this particular case study, all of the end devices are N-Ocean end devices, and between controllers, it was just too costly to open up the walls. This is a quite old construction, and it's not raised ceilings, so they actually had to open up the walls to pass wiring. So it was too expensive. So what they did is they went wireless even between controllers. So with the Zigbee mesh technology, the controllers basically form a wireless mesh network and can now basically automate all of the building and relay all of this information back to one centralized location, so that you can monitor and control every controller and every end devices in the building. And because there was no wiring labor, there was no dust hazard and no downtime. In some of these old schools, this wasn't the case in this one, but in some of these old constructions, sometimes when you open up walls, you're looking at asbestos for some of the insulation, and it could have exposed the occupants for all of these dust hazards. So this was all this wasn't an issue in this particular case because they didn't have to go that route. And the interface, they basically plugged all this into a standard BACnet IP building management system. So again, BACnet, a standard protocol which allows you to scale your system and ensure that your system is future-proof, so that you can add in other types of devices from different manufacturers without a problem. And as you can see, basically each zone is controlled by one controller, and each controller in its periphery is basically handling all of the end devices and allowing for scheduling, allowing for remote control, and many other types of features that way. And all of these things, especially scheduling, closing the lights when that classroom isn't being used automatically, it just makes a really big difference at the end of the year. And what they saved was 61% of electrical labor cost, which is huge. Labor costs are quite expensive these days. And they also saved 32% of controller cost by combining the HVAC and lighting into one box. Let's look at another case study. This one is a little different, and sort of want to illustrate one of the points that I made earlier on, where a lot of people are actually installing HVAC control systems year one because they have a limited budget, but they want to be able to be ready to scale it up and add lighting control eventually. So this is the exact case on this building here, where they wanted to control their VAV boxes, so their ventilation system, and they wanted to add in thermostats so that local occupants can adjust local temperature in all their different offices and conference rooms. But they also wanted to have all of this centrally managed through a centrally located schedule and a system. This is recently renovated office, and they realized that they could generate even more savings with lighting, and that's what they wanted to be able to do in the future. So when you look at what was actually installed, well, it was a couple controllers all meshed together with wireless Zigbee as well, so they didn't have to pass in networking wires between controllers. This was connected over Ethernet and IP LAN to the third-party BACnet IP system again. And every controller basically connected to a VAV box. And each VAV box, from a local control point of view, was allowing occupants to adjust their set point with an N-Ocean thermostat, which is as well a wireless end device. And now what they can do is they could very easily add on some wireless switches, some wireless relays, some light sensors, or some occupancy sensors, and now start to generate even more savings based on occupancy or by reducing the amount of hours lights are on. And they can do this very, very simply. Finally, another case study to illustrate, again, the HVAC example. This is a cardboard factory, fairly large, almost 500,000 square feet. They had 25 gas-fired unit heaters, and wiring was just very, very difficult. It required conduit, which added even more cost. And downtime really wasn't possible, because shutting down the factory even for a couple hours to start wiring the place up for your building automation solution would have cost major disruption, and would have been basically a no-go right from the start. What they did is they basically were able to centrally manage all of these heaters by installing controllers that are wirelessly meshed together. And as you can see, the savings in labor and material were quite high, and time on the job was greatly reduced, and this was all due to the wireless system. And this is another case where they decided, that year one they didn't want to install the lighting because it just didn't fit in their budget. But the system being fairly scalable, if they wanted next year, because the ROI on this particular project was less than 12 months, next year they could actually pay with the energy savings a lighting upgrade so that they can automate their lights as well and have the lights controlled, on a schedule. So that concludes the presentation part. I hope you found this interesting. I wanted to keep plenty of time for Q&A, so I will hand it over back to Mitchell and start combing all of your questions. So again, feel free to enter in your questions in the Q&A tool.
Thank you, Louis, very much for that great presentation. We actually do have quite a few questions here for you. So I will start here, which is a very appropriate question. Does SCL Elements provide training for performing these types of retrofits?
Yes, we basically have what we call our system integrator and partner training, where system integrators that specialize in building automation and some of our partners, either other manufacturers or consulting firms, will come in. It's a 2-day training, and we basically explain all the different options from everything from wired to wireless to from BACnet to lighting and HVAC.
That's great. Next question here. Are combined HVAC and lighting available for single-family residential new construction or just commercial buildings?
That's a good question. The focus has been really commercial buildings, but home automation is now becoming even more accessible to the market because of cost reductions. And what we're seeing is, senior residence, hotels, condo projects are now all installing combined HVAC and lighting. And it's a lot of people are I'd say are still forerunners or early adopters are now installing it in their actual houses or single homes, but it's still really in early adopting phase at that level. But when you look at condo projects or senior residence or any other type of multi-dwelling apartments, those are actually quite prevalent.
Okay, good answer to that question here. I want to thank the audience really quick. We're really being very attentive and submitting questions here, coming through at a very rapid pace. Louis, how do you ensure the HVAC and lighting wireless does not interfere with clients' federal security communications requirements?
Yeah, that's a good question. All of the different technologies that are available have been assigned different frequency bands and are also regulated quite strictly by the FCC. So, if you look at N-Ocean technology, it has in the U.S. it operates on the 315 megahertz band. The Zigbee operates at the 2.4 gigahertz band. Some folks will say, well, there might be some interference with Wi-Fi systems. Well, in fact, Zigbee has 2 channels which do not overlap with Wi-Fi, so there is no interference at that level. So all of these different systems, have their own spectrums, their limits in terms of broadcasting power or that the radio modules and antennas can broadcast. So it's all regulated, and it's now quite prevalent, and there really isn't issues that have been if you sort of look at the trade articles and publications, there really isn't anyone claiming that there is some interference. It's actually quite well managed.
All right. The next question here, referring to an earlier part of the presentation, when you mentioned $45,000 savings, or in savings and labor, excuse me, the attendees asking, I presume that compares to installing parallel systems, but what is the overall cost savings compared to not implementing something like this?
What are the overall...
I guess in addition to the savings and labor, if you were to not implement this?
Well, there's certainly different factors. if they had not implemented the system, they basically couldn't have had the energy savings, and they basically came up with a return on investment of less than a year. So this was a project which I believe was around 100K. It should have been 100K. It was a lot less than that, and the energy savings were a lot more than that. So the return on investment was actually quite significant. So what would have been the impact of not doing it? Basically, they probably would have never gone through with the project. When you look at the manufacturing sector, the typical return on investment that they require sometimes is 18 months and sometimes 12 months or less. Whereas, the commercial space, the return on investment that most folks are looking at is 2 to 3 years. And in institutional buildings, so municipal or governmental buildings, because they want to show leadership. A lot of times for some of the projects, they don't mind going all the way up to a 5-year ROI. So the return on investment that people and building owners are looking for really depends on what type of business they're in, but definitely the most constrained sector is really the manufacturing sector. They really have a high return rate on their money, and they need, for any investment, even if it's for energy saving, they have to generate that same return on investment and return on their investments. And if that's 12 months, then your system better be quite performant, or else it just won't see the light of day. I hope I answered the question. I'm not sure I totally grasped, but if you do want to resubmit or clarify, I'll be more than happy to.
Yeah, I think that was a great overview of at least giving a lot more information there. We have two that are very similar, but I'll start with the first one. Louis, is there an API for third parties to access your controller?
Yeah, well, basically, the controllers, what we wanted to do is support multi-protocol and all open protocols. So if you are using, the standard BACnet IP or BACnet Ethernet protocols, you can talk to the controllers. If, one of the most prevalent now protocols in the world is the HTTP protocol over IP. This is another protocol that we use to communicate with the controllers. So there's many different ways that you can talk to the controller from the building management system, and then on the downstream, communicating with end devices. That can be done with Modbus or Anocean or Zigbee, or just physical inputs and outputs, which are digital or analog. So it's what you're really looking for in a system is something that supports a variety of open protocols, so that you're not stuck with a proprietary system, and you're not going to be able to scale it up in a couple years from now, and really ensuring that you're future-proofing the solution. So in terms of APIs, you pick whatever you want. Do you want to talk to us from an end device perspective or from a building management system? We can do both.
All right, I think that answered the next follow-up question I had, and if not, I would ask the attendee to resubmit that question as well. The next question I have for you here, I'm sure this depends on the type of building and project you have, but if you have any idea of the typical cost per square feet for the combined scalable wireless system, someone was asking about that.
Yeah, that's a tough question. It really depends on how many control points you're going to be deploying per square feet. So let me expand on that a little bit. Remember that case study I presented to school, where all they did was have one controller which is controlling the lighting switches and the lighting relays, and one thermostat and the VAV box. Well, you're looking at a couple control points there. If you would have added on some CO2 sensors, some daylight harvesting sensors, some motion detectors, you could have added a lot more, control points, which obviously would have generated even more savings in terms of energy, but will cost you more right from the start. So it depends on, how much energy savings do you want to generate, and then from there, your cost per square foot will rise or decrease. Then it also depends on the complexity of your systems. If you're deploying a building office where you have a central air handling unit and you have a couple of VAV boxes, well, that's a quite simple project. But if you're looking at a hotel where each room has an individual heat pump, well, the complexity in each room just has risen, so your control system won't be comparable, per square feet. And so, and then it also really varies depending on what is the use of that building. Is it a hotel? Is it a building office? So it's kind of hard to answer that question, and it will vary greatly. The way the industry really works is they don't price it per square foot. They price it per control point. And that's a better way of trying to come up with a rule of thumb for how much will a system cost.
I think there was a follow-up to that question actually, Louis, and they were wondering if it was better to ask what's the cost per control point.
Yes, that's exactly it. Yeah, so it's much better to ask the cost per control point because that's really going to be the key factor in the cost of your building an automation solution.
Okay. One of the recent questions talking about one of the case studies, I believe. They said, I assume that the 4 to 10% lighting savings assumes that the existing system does not have motion sensors already installed. Is that correct?
That's correct, yeah. So, and that's a great question as well. I mean, those were typical numbers, right? So if you're just automating your light with a schedule, which is centrally controlled, and obviously depending on what are the office hours or what are the usage hours of that particular building. But then if you really go into more cost-effective solutions or solutions that will provide even more energy savings, like your question, where if you're adding a motion detector, if you're adding daylight harvesting sensors, now all of a sudden you can actually generate a lot more than 10% savings, and that can actually grow quite rapidly. And then it also has a great impact as well. Are you looking at a retrofit or is it a new building? If you're looking at a retrofit and you have old T12 lighting, we know T12 neon lighting is quite inefficient, and you put in a control solution on that, well, the energy savings are going to be a lot greater than if this is a new building and they're all deploying T8s or LED lighting, where you already have a quite optimized solution, and what you're doing with the lighting control is you're optimizing it even more, but going from 30 watts per neon to 23 with more modern technology, and then reducing that with control systems. Obviously, there's definitely going to be a direct link there. So, those numbers are really just typical numbers or average numbers, but they will definitely vary greatly.
That's a great answer. One that came in right when we started the Q&A. In your opinion, are there any benefits lost in using wireless control versus hardwired?
Any benefits lost? That's an interesting question. Would there be any benefits lost? I really can't see any. The only you really have to look at it from a cost perspective. If if you're looking at a new building and you don't have to open up walls and like you would have to do in a retrofit situation, then your wiring costs will be actually a lot lower in a new building scenario than a retrofit. And obviously, the wireless end devices, there is a little cost premium to them compared to wired end devices. So you really have to study, in my environment, what are my labor rates? How much is it going to cost me to wire them up versus paying a little premium for the end device, for the wireless end devices, but then save on the labor. And most of the time, it's going to be more economical to go the wireless route. But there are certain cases where there are certain types of sensors which the premium for the wireless may be a little bit too great, and going with a traditional wired sensor may be more cost advantage. So it's really about cost from a. Obviously, if you go the wireless virtual route, you're not hogging an I/O on your controller, so there's more room for future scalability. But at the end of the day, people always look at how much is it going to cost them and what's going to be cheaper.
I think that was a wonderful answer to that question. In terms of the range of the wireless controllers, Louis, is there a range in feet for these controllers?
Yeah, that's a good question, and that you have to look at the type of wireless technology that you're using. So I talked a lot about ANOcean and Zigbee, so let me give you concrete examples for ANOcean and Zigbee. With ANOcean, you're looking at self-powered end devices, which don't require any batteries. So that's quite interesting. Because you don't have any batteries, the range that you're going to get between the ANOcean end device and the controller obviously is going to be somewhat limited. And in a building, you're looking at about 50 feet to 90 feet, depending obviously on obstacles and wall composition. But within a zone, normally you're able to have 50 to 90 feet distance between the controllers and the end devices. Then with Zigbee, there are many Zigbee end devices as well out in the market. The advantage with Zigbee is that you get a greater range. The disadvantage is they have to be powered, either with 24 volts coming in from a transformer or batteries. So they have the disadvantage of requiring power, but they have greater range, obviously, because more power means more range out of your radio module. Now, with Zigbee, you're looking at anything between 100 feet to 300 feet between the controller and the end devices. And then when you look at the range between controllers, well, again, this will depend on obstacles and wall composition and other types of factors that way. But when you're looking at straight line of sight with Zigbee, we can actually reach a couple hundred feet. And within a building, what we say is 100 to 300 feet normally, and it really just depends on how many walls you need to go through with the system. But normally you have one controller per zone anyways, and each zone normally doesn't have subdivisions, so it normally provides great range that way.
Okay. Let's see. We might have answered this before, Louis, and I apologize for bringing it up again, but someone mentioned if there was an API other than the web interface available.
Yeah, you know what, I forgot to mention another key point when you did ask that question earlier on. Each controller is fully programmable, so you can basically program the controller to automate and control different systems in your building. And so it's basically a programming language. It's a scripting language. What we use is Lua. Lua was developed 20 years ago by a Brazilian university, and it's now actually quite prevalent in the industry. It's being used by the gaming industry, games like World of Warcraft, which are multi-user, multi-site games, are all based on Lua. It's now being used in industrial automation, and it's also starting to be used in building automation. So it's a fairly simple scripting language that you can just use simple if statement for while loops. It looks a lot like C code, and through this interface, you can basically write up specific behaviors in your controller. So this is an API which is totally open, which is open to any installer that wants to use the system. Then in terms of other APIs to talk to external systems, well then it comes down to the HTTP protocol or the BACnet protocol.
All right, well, I'm glad we were able to touch on that once more. Let's see, in terms of the next question, well, someone wanted to you to go over just once more the energy savings in the case studies you had mentioned. Maybe they had missed the information during the talk about them, but
yeah, no, that's a good question. I actually didn't talk about that. What I wanted to illustrate was really the cost savings of combining the HVAC and lighting. In terms of the elementary school, this is something that is actually a project which is actually now ongoing metering, and they're actually going to be evaluating, practically what are the energy savings. From a theoretical point of view, they're looking at about 20 to 25%, but that's the theory. In practice, it's always good to sub-meter and meter the savings and do it across a full year. So those are numbers that I actually don't have to share. The cardboard box factory, this is one that was a very large energy guzzler. I actually don't have numbers in front of me, so I do apologize for that. I should have thought of that. Probably something we should be publishing on our website shortly.
okay. Well, it looks like we have time for about one more question here, Louis, and I just want to leave it with you and a bit of advice for everyone here today in terms of looking into these wireless controls and technologies. Just any last advice for them if they're getting started on a project or looking into it?
Yeah, so, last word of advice, obviously, choose a system which supports open protocols. Don't make the mistake of using a proprietary system with proprietary protocols. That will lock you in with that system, and it won't be future-proof. Ensure that the system that you're using, even if you're only planning on installing HVAC control or lighting control from day one, ensure that that system is going to be able to scale to HVAC to lighting or lighting to HVAC. That's very important. It'll allow you to generate even more energy savings down the road, and make sure that the controllers that you're installing are multi-purpose controllers so that they can handle both of those applications in one box. That's very important. And then from a wireless perspective, wireless is great for retrofit applications, and it's really a no-brainer. When you're looking at a new building, it's really a cost evaluation. What is the best system? Definitely, you're always going to be winning with a combined HVAC and lighting system. The only decision you need to take is, what are the end devices and what are the control points that I want to use, and do I want to have a mix of wired and wireless? Most cases, that's what you're going to have. It's not about going all wireless. It's about less wires. It's focusing on I'll use all of the very cheap wired end devices that I can, because wiring them up is going to be not very expensive in my new building. But for some of the more end devices that are a little bit further, or motion detectors. Motion detectors in many cases are not well placed from day one, and then you have to rip them out, bring the wire, and put it at another place. Or sometimes you have to add in more motion sensors to properly cover your area. Well, with a wireless motion sensor, if you realize that it was misplaced, well, just unglue it from the wall and glue it somewhere else. No wires to repass. So it's really just taking the time to do the cost analysis and really making sure that you're partnering up with a system integrator that has experience in deploying these these wired and wireless systems. If you're partnering with someone that has done it before, you're definitely going to be in good hands.
All right, great piece of advice there for everyone. Well, we are about out of time here. We want to give everybody a chance to explore the community. I want to mention again that our sponsor today is SourceCore Professional Services. You'll find a link to their virtual booth advertising their educational information about the sustainable tax credit over in their button that says this webcast sponsored by. If you click on that, you'll be taken to their area. If you have any other questions for Louis and SCL Elements, be sure to send him an email and visit their website, which we have up on the slides there. Thank you for joining us, Louis, again today. That was a very great presentation.
Well, thank you for the opportunity, Mitchell.
Yeah, we had a great audience today. I want to thank everyone who attended. We hope to see you at our next Green Building Online Event Series broadcast. In the meantime, be sure to check out our community here and check out the latest edition of the Green Building Journal. We will see you next time.